Let's continue adding and subtracting fractions now. And we've seen our first example on the previous video. We had two fractions with different denominators. We converted those two denominators into the same value. We did that by multiplying both parts of one fraction by 2, which then allowed us to add the pieces together. Let's have a look at this situation. Well, my first thought is I need to make the denominators the same, so that all the pieces are the same size. I'm then thinking, how do I make those denominators match? I can't multiply 3 by anything to make 8, but the times tables of 8 and 3 must meet somewhere. Let's work this out. 3, 6, 9, 12, 15, 18, 21, 24, 27. Eight, 16, 24. Aha! I'm going to multiply both parts of both fractions. When I multiply 8, my aim is to multiply it by something to make 24. I'm then going to multiply 3 by something to make 24. Then they will have the same denominator. You'll notice there are no numbers lower than 24 where they meet. This means I'm going to be quite efficient. So, in order to make sure I've labelled this in a way that follows, I'm going to put a pair of little arrows here. Now, to get 8 to become 24, I've had to times by 3. 1, 2, 3. I'm going to write times by 3 twice over here to remind me that it's both the numerator and denominator that I'm multiplying. So that becomes 9. Over here, to get 3 to become 24, I'm going to have to multiply by 8. 1, 2, 3, 4, 5, 6, 7, 8. So I multiply my 1 by 8 as well. Before, we wrote our equivalent fractions like this. Unfortunately, setting them out side by side here doesn't help in your layout for your adding and subtracting. So what you've done effectively is you've done it here and here. And then here and here. So you're having to change your line from looking across to looking down. So keep the arrows, and that will make that much easier. Now that you have the same denominator, you can add away. Result. Let's try another one. If you want to pause the video and attempt to do the question before I attempt it, that can be a very productive idea, because you should always want to work it out for yourself. So my first thought, how do I find a number where the denominators can meet? I want to look at the 4 and the 6 times tables. Some of you will have spotted it already, but not everyone. 4, 8, 12, 16, 20, 24, 28. 6, 12, aha. If I'd carried on past 12, I'd have also got 24. But 12 is the first time they meet, and that will keep the numbers as easy as possible. So I'm going to, like up here, multiply both parts so that 12 becomes my denominator. So over here I need to multiply by 3. Over here I'm going to multiply by 2. Hopefully some of you worked that out for yourselves already. Well done if you did. Let's try subtraction now. So, where do the times tables meet? I'm going to write the 4 times tables down first because I think the 11s will be quite easy to do in my head. But if you're not comfortable with that, you can write them both down. Aha, 44. Go back and check there's nothing lower. And if you want to, write the 11s out so you can see those too. Okay, 44 it is. So what am I timesing both bits by here? Well, I'm timesing both bits by 4. So that gives me 40. And over here, what am I timesing both bits by? 11. So that gives me 33. Now, if you remember from the previous, subtraction is just the same as adding. You've got 44 bits that are this size, taking away 33 bits that are the same size. So that leaves me with 7 bits. So subtraction is just the same as addition. In the next video, we'll look at what happens when things start to get a little bit trickier, because we haven't looked at simplifying and we haven't looked at mixed and improper numbers and how they come into play.